or solving by substitution. So mostly we had yesterday where we had two equations that were set equal to each other, I believe, and then we just knew they were, they were both equal to y, so they were both equal to each other. And today, remember the first rule is always have one equation solve for either x or y. And sometimes we don't. In this case, we do. It tells us y is 3x plus 4. So again, anywhere there's a y, I can put a 3x minus 4. They're interchangeable. So I'm going to, instead of putting that y, I'm going to put my 3x minus 4. So 2x plus 5 times this whole 3x minus 4 that I'm substituting in. Let's do this. This is actually from the substitution part. The rest is just the equation that was there. So then back to my blue, it equals 19. So this is just this equation rewritten, substituting in 3x minus 4 for my y. So I'm going to simplify this. I have to do distribution. So I have negative 2x plus 5 times 4, which is 15x, minus 5 times 4, 20, equals 19. Combine like terms. Remember, we don't add or subtract the x's to the other side yet. We have x's together. We have to combine. So you have 15, somebody took 2 away from you, so 13x on this side, minus 20, equals 19. So there we're as simplified as we can get as far as we've combined all of our like terms. So now we can do our regular, so move everything away from the variable. So we're going to add 20 to both sides. And you get 13x equals 39. So x, then hopefully we know by this point we divide by 13 to get x alone. And you get x equals 3. So again, we still have to find y, but we're going to take that 3, and now we're going to substitute that in. I'm going to put it right there. So I'm going to write 3 times the 3 that I'm substituting in, minus 4, and that's going to equal my y. So 9 minus 4 equals my y, so y has to be 5. So I'm going to try that. Remember, our answers are ordered pair, so my answer is 3 from the x, 5 from the y. I'm going to try it in the other equation. So I'm going to go back to this equation, the green, and I'm going to put in negative 2 and my x, which is 3, plus 5 and my y, which is 5. And see, does that equal 19? That's my check. So this would be negative 6 plus 25. And negative 6 plus 25 does equal 19. So I checked it, and we know it's right. So works in both equations. We did one here. That's how we got that one, and the other one there. So my answer is this 3, 5, this ordered pair. So next up, again, solve by substitution. It's set up again beautifully where y is 3x minus 11. So wherever there's a y, I can replace it with a 3x minus 11. That's in this equation. So I have y, 3x minus 11, minus the 3x equals negative 13. So this one I don't have anything to distribute, but I have 3x minus 11 minus 3x equals negative 13. Combine my like terms, 3x minus 3x, that's no x's. So I have negative 11 equals negative 13. And again, like yesterday, this is never true. Negative 11 can never equal negative 13. So this is no solution. So I can't get an answer. There is no place where those two lines intersect. Let's see. Here again, we'll start with the blue. X equals. Tell me wherever there is an x, I can replace it with negative 2y plus 4. So I'm going to rewrite this equation. I have 2, there's my x, negative 2y plus 4, plus 4y equals 8. So I'm rewriting this equation right here. That's this equation. Again, I have to distribute this. So that would be negative 4y plus 8 plus 4y equals 8. Hey, negative 4y, 4y. We have no y's left, but we have 8 equals 8, which is always true. 8 always equals 8. So this is infinitely many solutions. Infinitely many solutions. Because we have a true statement, we've got no x's or y's left, we just have 8 equals 8. Tell me whether the system has one solution, infinitely many solutions, or no solutions. So we have to either do one of two things. We can rearrange the equation to see what the slopes are. Like this one, I know the slope is 2. If I rearrange this one, but this might be a waste of our time in the overall scheme of things, unless we just want to know how many solutions there are. But I have negative 2y equals negative 4x plus 6. I divide by negative 2, I would get y equals 2x minus 3. So if I see here it's 2x plus 1, here it's 2x minus 3, those are going to be parallel lines. One starts at 1 and has a slope of 2 up 2 over 1, and one starts at negative 3 and has a slope of up 2 over 1. So that would be the other one. So they are parallel lines, so this has no solution. This one, we already have the slope here, m equals negative 1. If I want to rearrange this, I'd subtract my x's to the other side, and I would get 3y equals negative 3x plus 12 still. I'm going to divide everything by the 3, and I get y equals negative x plus 4. Negative x plus 4, my slope here is also negative 1. My y-intercept is 4. So these end up being the same line. So this is infinitely many solutions. It's just different ways of writing the same line. And here we have a slope of 1. Rearranging this equation, this time I'm actually, well, I guess I won't change the rules partway through the year, equals 38. First thing we normally do, subtract 2x. I get 2y equals negative 2x plus 38. Divide by 2. And get y equals negative x plus 19. These have different slopes, so if they have different slopes, they are going to intersect someplace. We could graph them and find out where they intersect. We could solve it by setting them by substitution and see where they intersect, but it just said how many answers are there, how many solutions. So this has one solution. I know it's 2 lines. If I graph them, it's going to intersect somewhere. Error analysis. Describe the correct and correct the error at the right in finding the solution of the following system. So step 1, x plus 8y equals 21, x equals, it looks like, what did they do in this first step? It looks like they did that. So far I like it. X equals 21 minus 8y. Step 2, x plus 8y equals 21. So now they're saying x is this, right? So anywhere there's an x, I can substitute in 21 minus 8y. The only problem is, this is this equation, right? So you can't substitute it into that equation. You have to substitute it in the other equation. So the other equation, which is 7x plus 5y, equals 14, that's the one I have to substitute it in for, because I got x equals 21 minus 8y from the other equation. So instead of that, I'm going to put, instead of x, we're going to put in 21 minus 8y plus my 5y equals 14. Let's correct their mistake. So 7 times 21, of course I have a calculator handy, hold on. 7 times 21, 147. Well, that was interesting. 147. Let's pause for a short station break, I guess. Alright, one more time. 147 minus 56y plus 5y equals 14. Let's see, I have some terms I can get combined. So I have 147 minus 51y equals 14. Get the y's by themselves. So I'm going to subtract 147. And you get negative 51y equals 147. This would be negative 130. This is not a pretty answer. I divide by negative 51, unless I did something wrong here. And I get y equals 130 over 51. But let me check my work. So, again, well, if my computer's going to work, 21 minus 8y is what we're substituting, and we have 7x plus 5y equals 14. 7x, 21 minus 8y, 21 times 7 equals 147. 7 times 8 is 56. Plus 5y. Yeah, it looks right. So that is not a beautiful answer. I'm sorry, my computer is jumping all over. But so that's my answer for y. I have to plug that in and find x, which is going to be messy. Somewhere on there we had x equals 21 minus 8y. X equals 21 minus 8y. So x would equal 21 minus 8 times 130 over 51. And, let's see, 130 divided by 51 times 8. Yeah, this is an ugly number. I think I get 31 over 51. Let me just verify it one more time. 21 minus 8 times 130 divided by 51. Yeah, 31 over 51. So that would be our x value. So my order pair is really ugly. It's 31 over 51 and 130 over 51. That's not pretty. Alright, let's see. Looks like we have one left. If we can get back to it. Alright. You know what, let's call it quits. If I can get us to quit.